Today we're going to learn how to graph a rational function. In order to graph a rational function, we first need to find each of these 6 things. Once you have all 6, you'll be able to draw a pretty accurate graph of your function. So we're going to start with the graph of 2x minus 1 over x. So the first thing we're going to find is the domain. Now we know the domain would be all reals except where the denominator is 0. So this will be all reals except for 0. And you can find these in any order you like. We look for the x-intercepts. That would be where our function is equal to 0, right? We set y equal to 0. This is where 2x minus 1 is equal to 0. And that's at x equals 1/2. Then we find our y-intercept. That happens when x is equal to 0. And we end up with something that's undefined, so that tells us that there are no y-intercepts. So that means that our graph cannot cross the y-axis. Number 4, let's look for those vertical asymptotes. That happens where the denominator is equal to 0. Number 5 would be our horizontal. And it looks like the degrees of our numerator and denominator are both equal, so our horizontal asymptote is 2 over 1, or just plain old 2. And last, we check our symmetry. We'd like to see if this function is even, odd, or neither. We end up with negative 2x minus 1 over negative x, which is not equal to f of x, nor is it equal to the negation. So that means that our function is not odd and it's not even. So whatever we draw should not have symmetry with respect to the y-axis or symmetry with respect to the origin. Okay, so I'm going to start labeling my axes. I'm going to call this 1, 2, 3. 1, 2, 3. And we know that we have a horizontal asymptote at y equals 2, so I'm going to draw that in. Here's our horizontal. We've got a vertical asymptote at x equals 0. And we've got an x-intercept at x equals 1/2. Now notice how our asymptotes broke our plane into 4 quadrants again, right? We've got this area, here, here, and here. Now we know that part of our function must exist here because we already have an x-intercept. So I'm going to draw something that goes through this point and is asymptotic to y equals 2 and also x equals 0. And it would look something like this. Now we can't have another part of the function up here because then our graph would not pass the vertical line test. So we need to decide if the other part of our function lies here, up above the horizontal asymptote, or below. And the answer is above. And the reason is, if we draw the graph below, we'd pass through the x-axis another time, but we only found one x-intercept, so we may only pass through the x-axis one time. So this function has a domain of all reals except for x equals 0. We've got our x-intercept at x equals 1/2. We don't have any y-intercepts. We've got our vertical asymptote and we've got our horizontal asymptote. And what we drew is not odd and it's also not even. And the last thing we need to do is label And that's it.